Good day and welcome to today's class. Today's class is a continuation of our previous classes on SS3 Further Mathematics, where we started the topic of inequalities. At the last class, we were looking at inequalities, quadratic inequalities. We said we are to solve quadratic inequalities and inequalities in 2 dimensions. At the last class, we were able to look at solving quadratic inequalities in 1 variable where we have only unknowns, and I gave you so many examples on them where I defined a quadratic inequality as an inequality where one side of the inequality is said to be a quadratic expression, and we're able to look at how to get the solutions of that inequality, where I gave you the diagram, how to represent it using the diagram, and how to find the intercept on the x-axis, and as well as know which of the area to shade or which of the areas the question is asking you to find. So we're able to solve a lot of exercises, and we did justice to quadratic inequality. So in today's class, we shall take the second aspect of that objective, which says it is solving inequalities in 2 variables. So in solving inequalities in 2 variables, we shall look at linear inequalities in 2 variables. Linear inequality in 2 variables talks about 2 unknowns, for example, x and y, which we shall be using throughout this course. The graph of linear inequalities in 2 variables is said to be a linear graph. For example, it looks something like this, where this is your y-axis and this is your x-axis. This is the positive x-axis, positive y-axis, negative x and negative y-axis. This point is said to be the origin. Now, just like I said, linear inequalities in 2 variables is said to be a straight line graph because it is linear, meaning it has only one intercept on the x-axis. Now, you may have something like this. This is an example of a linear inequality graph, which is a straight line graph, just like I said, and it divides this graph into 2 planes. We may have this to be plane 1, that is, all this region is said to be plane 1, and this other region is plane 2. So when you have been able to sketch the linear inequality graph, you shall then use the question to determine if region 1 is the required region or region 2 is the required region. Now, when you're able to sketch the graph, first and foremost, you find the value of y when x is equal to 0, and find the value of x when y is equal to 0. Now, when you do this, it gives you the x and y intercept, which enables you to sketch your graph. When that is done, you can then test to know if region 1 is the required region or region 2. How do we do that? It is best advised that you use the origin to determine which region it falls. When that is being determined, it will now inform you if you are to shade region 1 or region 2. Also, in linear inequality in 2 variables, when we have strict inequality, for example, greater than, less than, or greater than, the graph is a dashed line. If the inequality is not strict, that is, less than or equal to, greater than or equal to, the graph is a solid line. Now, this informs us that if it is a dashed line, it means that, dashed line as in broken line, it means that the inequality does not include the line, but if it is a solid line, it therefore means that the line is inclusive. So we shall be solving Questions on inequalities in two variables. Example 1.